Do you know what goes well with pot stickers? Well, that's right. Making a short little calculus related video. Just put me in the mood. So we're going to do a couple of examples of parametric equations of a line. And I've got it set up so that we can look at a two-dimensional example. And you might see parametric equations in a pre-calculus class. And certainly comes up in second semester calculus or calculus BC, and definitely in multivariable or vector calculus as well. So we're going to do two simple examples here. This first example will be a line that begins at the point 1, 3 and goes towards and passes through the point 8, 0. And so assuming that we have ourselves the x-axis here and the y-axis here, the point 1, 3 might be right about here. And the point 8, 0 might be right about here. And so what we're looking at is not in a line like in the equation of a line sense typical, but more like in geometry array. We're going to start here, we're going to go that direction. And it continues forward. It's not a vector. It would keep moving on from there, but I didn't build a larger graph. So in order to do this, it's like we've surgically separated our elementary algebra knowledge, and we're going to look at what happens with x, where does it start, and where does it go? What happens with the y value, where does it start, which way does it go? And as we add other dimensions, we can add other components to our parametric equations. So let me just scroll up here a little bit. And just as a recollection, we have these equations, parametric form, and like they indicate down here, we're going to have a separate equation for x and a separate equation for y. And so what is going on with x? Well, x begins, its little journey starts at 1, and then we can see here by looking at the coordinates, it starts at 1, but it goes towards 8. Well, that's 7 units. And so that would be literally the change in x. Delta x would be 7. And then the y value starts at 3. So what is y value doing? Well, y changes from 3 to 0. So that's a loss of 3 units. So delta y would be a -3. So our parametric equations, x would be 1 plus 7t, and y would be 3 minus 3t. So let me just put little brackets on this now for our solution, and then we slide her up a little bit here. Just a quick little verification of what's going on. If you were to let t equals 0 in our equations, you would literally end up with x and y coordinates of 1 would be the x value, and 3 would be the y value. I'm going to let you do that substitution. Let t be 0. See what happens. If t equals 1, again, we'll go back here. If t equals 1, you're going to get 1 plus 7 would be 8. That would be the x value, and 3 minus 3 would be 0. That would be the y value, of course, because it has to pass through the point 8, 0. And then finally, if you were to go t equals 2, a little more calculation, you'd see that x increases by 7 more, and that's going to be 15, and y decreases 3 more, so that would be -3. So every unit of time, x would increase by 7, y would decrease by 3. This is just scratching the surface of where we're going in the course, but the two-dimensional equation is pretty straightforward. Okay, again, don't forget you have a pause button. You can always go back, re-listen, and compute on scratch paper. All right, three-dimensional example. you'll see here we're just going to add another component for what is z doing. Where does it start? Where does it go? Each one of these components is like independently saying what are the variables doing. In this particular problem, we can see exactly that x, y, and z begin at 2 and -7 and 1. But what's going on with the change of x and the change of y and the change of z? Whoops. All right, there we go. So x is changing from 2 to 4, so that's going to be an increase of 2. What's y doing? Well, that's right, it's increasing by quite a bit. From -7 to 5 is an increase of 12. And z, what's z doing? What is the change of z? Z is decreasing by 6. And again, we're not drawing this particular problem, so the size of the numerical values don't bother me so much. If we put it into our parametric form, we're going to get x begins at 2 and increases by 2 for every unit of time. Whoops, that was a little bit strange. Y begins at -7 and increases by 12 units for every unit of time. Z begins at 1 and it decreases by 6 for every unit of time. And this, my students, would be the set of parametric equations to represent that line from 2, -7, 1 moving forward. One little quick thing before we end the video. If the video says words like begin or start or from, words like this, we're going to assume that we're going to be starting from t is 0, and unless you've built a time machine, time can't go negative, time's got to go forward. If the problem tells us to start at some different time, we could do so, but most of our examples will begin from time 0 and assume that for each example. Thanks a lot.